Hello everyone, my name is Michael and today we're going to take a look at some ransomware. Now this sample is actually a pretty old ransomware from I believe 2016-ish. I figured I'd kind of overview it because it's got some interesting bugs that I want to go over that actually back then I actually personally kind of looked into decrypting it myself, and I've learned quite a bit since then. So I can kind of figure out why I couldn't decrypt it back then because of the bugs. So as normal, I would take it into Detect It Easy, kind of see what we're dealing with. We see we're dealing with .NET, specifically possibly VB.NET, so it might have been compiled from Virtual or Visual Basic. So we'll take it into DNSpy, and we'll see it calls itself CryptoLocker with a K, because K is cooler. And okay, copyright 2016. All right, so let's take a look at what we're dealing with here. Now, we can also kind of tell it was from Visual Basic likely because it's got these namespaces of .my. That's usually an indicator of that with the my application, my computer, my project, all that garbage. So let's go ahead and take a look at the entry point. And this is pretty typical for a Visual Basic as well. We'll see it's kind of a basic application.run. So if we were to jump into this, it's not gonna let us like easily see where we're going from here. So this is all actually like part of that. So let's go back, and actually what I'm probably interested in is the main namespace here. So we have a form 1 and we have an HTTP class. Let's just take a look at that real quick. So we see this is just kind of a quick little function for talking to a server and apparently posing as an iPhone. Okay. And Safari on iPhone for some reason. Okay. So we'll probably not mess with that. Let's take a look at the constructor. And actually the wrong constructor, this constructor. So we'll see, usually in .NET you'll have a form load, and that's probably going to be where we have all our actual code. And okay, yep, this looks interesting. So we see something goofy here with reading a file, reading the file itself as a string. Okay. We have a random, and we have Mr. King Des here with a bunch of random characters, including some UTF-8 or 16 characters, whatever. And this .key, that sounds like something we want to watch. Okay. And we'll take a look through here. We go into a big loop, and we're adding to that key. So I'm going to bet this is our keygen. All right, so taking a cursory look through here, we're still continuing all in the same function here. It's not segmented very well. We're first going to get the startup path of our application. We're going to get all files, so all files from wherever this is running from, and apparently we're going to crypt each file. If we keep scrolling down, we have copy-paste code for the desktop, copy-paste for my pictures, my music, personal, which is like the root user folder, and that already tells us this is kind of a noobish person. You normally actually be a little more efficient and put that in a loop. So if we take a look at our crypt function here, all right, so we read in the file all into one array, which that can cause problems if the file's really big, or if you ran out of RAM or something. But anyway, let's just pretend that this works. And we're going to turn it into a string, and then encrypt the string, and then turn the string back to bytes, and then actually write that to the file with a .erbst. So, okay, so it looks like if we're going to believe their naming here, we have an AES encrypt function that we're passing our key. All right. And okay, yep, they do use Rigendale. Looks like we're using MD5. Let's follow the password. Okay, so they're computing. Okay, so they're taking the password, doing an MD5 hash of it into this variable here. Then they allocate a 32-byte array and copy the MD5 twice. However, as we'll see in the debugger later, they make a little mistake here. It's not just taking the MD5 and concatenating it to itself. It's actually overwriting a byte because this is 15. This should be a 16. So basically it ends up where it's not just two MD5s thrown together. It's a little goofy. So anyway, we go into, okay, so we have 32 bytes to the key, so that means it's going to be AES 256. We're going to use ECB mode, make a translator thing. All right, input was our string, and we're going to turn that into bytes. We're going to encrypt it, then we're going to turn that into base 64 and return that. Okay, that's quite a bit there. That turns into a string, which then goes to bytes and then writes that to the file. So it looks like we're probably going to see some base 64 actually in the encrypted file. Now, I think that's pretty much it for what we have. We also have a nice handy dandy decrypt function here. So that kind of at least tells us the logic of how to reverse that encryption. That's nice of them. So let's go ahead, and since we know this is where we want to kind of start debugging, let's go ahead and do that. So, all right, let's start debugging. And like I said, this is just like boilerplate stuff. We can ignore that. And all right, here we go. So we'll see location is going to be our path to our executable here. All right, so for whatever reason, what are they doing with that? Turn it to a string. Are they going to like copy themselves to somewhere? Nope. Okay. They just do that for the fun of it? I don't see it referenced anywhere else. Alrighty, cool. Okay, so we're going to get a random instance here. Now, the fun part about random is that it's based off the system clock, kinda. It's actually like the ticks since the system started up. So let's jump into that. We'll see here by default the constructor is passed environment tick count. Let's go ahead and see what that becomes. And all right, so our seed for this run is this value. Let's just grab a notepad and keep this safe in RAM where it can't be encrypted. So that's our seed. Okay. Let's go ahead and let this initialize the algorithm. And go back up the constructor. All right, so we have our text here. That's going to be used as a char set. And we're going to use our random instance, generate two numbers here from 0 to 9 billion or whatever that is. And we have two numbers built as our key so far. So let's go ahead and let's see what our key is so far. Now the fun part here is that dnSpy organizes not just alphabetically, but like case sensitive alphabetically. So we have to go past all the capital letters, which it's really struggling with. And my scroll finger is really struggling with. There might be an easier way to get to this if anyone knows. Almost there. All right, there we go. Key. All right, we want to watch on this. Now, note I'm using an old version of dnSpy because I don't care to take the time to install .NET 4.7 on this really old VM. So I can't add a watch to this. It's kind of annoying. But here's our key so far. We have two big numbers. Okay. So we're going to then go into our loop. And we're going to generate a random number between 0 and the length of our text, which is Mr. King Des here. And so basically we're going to pick a random number from that. And it looks like this roll we get this kanji. All right. Let's loop this a couple times. We get a G. Okay. Loop a couple times. We get another kanji. All right. Let's go ahead and break to the end. I want to see what the total key is. And ooh, that is a very long key. I think it's like some 5,000 characters or something. So DNSpy is not going to show us the whole thing. Let's go ahead and save that to the desktop and call it key.bin. Just dump the binary of it. Oops. Let's take a look at it in here. Okay, so there's two things that we need to note here. First off, as we confirmed, it's really stinking long. In this case, I speak decimal, 11,000. All right, 11,000 some. Now, this is technically not a static length because the first part here are two numbers that are random between 0 and 9 million or whatever. So technically, it could possibly get a shorter number. Most of the time that I run it, it ends up with two even numbered here. So, but the other thing is we notice all these zeros in between. That's because this is Unicode. So because of our fun little kanji, it has to actually use 2 bytes to store each character. So our regular ASCII characters just have a 0 in them, but some of these characters have to be stored as 2 bytes. And HXD isn't going to display that right because it's assuming ANSI here. I'm sure there's a way to make it actually display right, but I'm not going to dig through that. All right, so here we have our key that's generated. Cool. Let's just leave that there. All right. So next, let's go ahead and jump into some encryption. Now it's going to grab the startup path of where it's running, which is running from my desktop. And all right, so we have our first file, our first victim file. Let's step into it. Yes, getter for the name. All right, cool. We are here. All right, so path. Now we'll notice it's going to try and encrypt itself. Not very smart. Let's edit this. I don't feel like messing with that. Let's go ahead and got to keep it in quotes because it's a string, and we have to escape. So let's I don't know. Let's encrypt a file that I want to tell it to encrypt. Zeros.jpg. So that is just a bait file here, zeros. It is just a bunch of 0 bytes. So we can kind of see what's going on here. So, all right. Let's go ahead and follow this. So we're going to read the entire file into one variable. There we go. And we'll see expanding 10,000 childs. Nothing but zeros. All right. Now we're going to turn it into a string using the default encoding. Okay. Go ahead and do that. And we'll see string becomes a bunch of escaped zeros. So it becomes a string of zeros, but they actually have these slashes. So that's interesting because that represents a 0 byte. Okay. So we're going to go ahead and encrypt our zeros. All right, so we're being passed our password. Now it displays okay here because it's Unicode. Then we have our input of the /0/0 chain. So let's fire up a Original instance. Let's fire up a MD5 instance. We're going to have a destination array, which is going to end up being our actual AES key. And right now it's initialized to a bunch of 0 bytes. Let's go ahead and, all right, so they're taking that MD5 and we're copying it into the beginning of our buffer. All right. So that's the first 16 bytes. Now we're going to watch here. You'd expect there to be E610D8 right after here. However, notice they just overwrote the 15. So once again, that 15 should have been a 16. And then we have a 0 byte at the end. So that's a little goofy, but whatever. As long as we can reproduce it. So we assign that as our key. And all right, let's go ahead and I think I can grab this. Can I? Does this old version let me? No. Let's go ahead and there should be a save. There we go. ASCII.bin. So let's take a look at this. Oops, wrong one. All right, so here's our AES key. You'll see there's the repeating MD5, but chopped off the 58, let a 0 at the bottom, whatever. All right, so let's get back to our function here. All right, we set our key, tell it ECB mode, create an encryptor. All right, here's going to be something interesting. So we have our input, which is this goofy escaped bytes array. Excuse me. Now we're going to explicitly turn it into bytes, assuming that it is ASCII. Now, we'll see later on why this is a problem. So, all right, so now we have bytes. And let's take a quick look at that. Yes, expand it. And okay, so since that string is a bunch of escaped 0 bytes, this file turns out okay. So it's okay. It's a bunch of 0 bytes. That's what we expect. So we're gonna encrypt it with AES 256, and then we're gonna base 64 encode that. All right. So here's our base 64 of our encrypted file. All right. Let's go ahead and return that. Turn that to a string. Then let's go ahead and turn that into bytes. Because why not? Let's just do a million operations of flipping between bytes and strings. And becomes, I'm looking at the wrong one. That got me confused there. Bytes 2. Bytes 2 is our encrypted bytes. And we'll see these are ASCII characters. So that's the ASCII of our base 64. All right, let's open up a new file with the .erbst extension. It took a second. There's our file. Let's go ahead and write our bytes to it. Dispose. And delete the original. All right. There goes our lovely zeros. Oop, can't read it because it's gone. All right. All right, so here's our encrypted bytes here. And you'll see there's a repeating pattern. That's because of the ECB byte block mode. So every 16 bytes of the ciphertext is the same, which translates into this many base 64 bytes. So let's go ahead and we have enough information. Let's try to decrypt this since we stole the key. Now, realistically, we can brute force the key in this case, but we'll see why that's going to cause some problems later. Let's go ahead and use crypto tester, and let's try to decrypt this. I'm going to grab a healthy amount of data here. Let's go ahead and input as base 64. All right, so that decodes to, as we see here, ECB is a repeating cipher, basically. So we stole the key. We have an AES key right here. We need to go to AES, ECB. By default, it technically uses PKCS 7 but for padding, but we're not going to care about that. And decrypt. All right, so we have our lovely zeros back. So you would think, all right, let's build a decryptor, patch it, get it out the door. That's what I tried to do several years ago. Then I ran into a bug when I tried to decrypt actual files. Let's find out what happens there. So we are, all right, so we're going to try to encrypt ourselves again, I think. Where are we? So we just encrypted a file. All right, let's loop, go to the next file. And yep, the getter. All right, let's change this. Oh, now it's going to try to encrypt the crypto tester. All right, let's change that. Let's tell it to encrypt a file we want to for speed here, because this is a very slow ransomware. As you see, we're switching between bytes to strings to bytes to base 64, reading it all on one. It's a mess. It's really slow. So we're gonna do the DNE and chrysanthemum. How many times I've had to spell that? All right, so let's go ahead and watch that get encrypted. Read the whole thing into memory. All right. D6B22, that's, I recognize that as the length. And we'll see here, this is the JPEG header. So these are FFD8, FFEO. And then there's some zero sections, some FFE. That's just something I would recognize as a JPEG. So we're going to turn that into a string. And we'll see our Yoya. That's also another, that's the string version of it. And we'll see some escaped things here. So we have these are the actual byte values that are being escaped. And with the /u means it's a Unicode. Unicode 0001, Unicode 0002. So all would be okay if they continued on this goofy path. But as we'll see here, let's go ahead and jump into encryption function. Build our key, our MD5 goofiness. All right. Now here's the other bug. Note that we're using ASCII. These are not ASCII characters. So what happens? They get turned into garbage. All right, what's a 3F? Let's open this up. 3F. I hate that. 3F. That is literally a question mark. So it gets turned into a question mark because it's not a valid ASCII character. I believe you can pass a flag to tell it what to do if there's an error, like actually throw an exception or return null or something, but they shouldn't have done this at all. So anyway, let's continue. So AES encrypt that, then turn it into base 64. And that's some weird looking base 64. But it is valid base 64. All right. So this is what we're going to see in our encrypted file. All right. Then we turn that into bytes and write it to the file with the .erbst. Delete the original. Okay. So our beloved chrysanthemum has been encrypted. What shall we do? Let's try to decrypt it with our key we stole. Let's go ahead and import that as base 64. All right. We already have our key in place. And it kind of looks like the chrysanthemum file, maybe. Maybe not really. Let's see, is this still a bug? It's still a bug. Okay, so I'm going to have to save this stream. Let's just save it to here. Dump that in. Alright, so let's compare. our poor files here. So we have the dump. And we'll see here, yep, there's our question marks. So each of those bytes that were not in the ASCII range got lost completely. There's no recovering these values. Now you could probably, like, if you know the file format, you could probably rebuild some of this. Like some of these bytes are like the magic header, and I don't know the full spec of that, but let's compare it to the original. As I switch between here, you can see what's missing, like these BFs and all that stuff. So that poses a big problem. Even the criminals cannot recover some files. Now, some file types, as we saw, the zeros were totally fine. If it's a text file, it's probably going to be fine. If it's like a Word document, the actual contents of it will be okay, but it probably will lose some styling and might need some tweaking to like recover the text, but it'd be kind of okay. Pretty sure like a database or a virtual machine would be completely gone. So it's quite a shame. It's quite a shame when you run into bugs like this. So we'll go ahead and let's go ahead and just let it run its course. And we'll see it's pretty darn slow because it's so inefficient. I think it literally takes like 5 or 10 minutes to run, which is a shame. I probably could patch out. We'll see it did do the desktop, so it's at least got past the desktop. I kind of do want to display the final bug if it doesn't take too long here. The longest part's going to be the user folder. Let's pause it, see where it's at. All right, that's a AES matrix there. Encryption transform. All right, so we are currently encrypting some type of a JPEG, which is going to get some data lost. Oh, it's in my pictures. All right. Let's see if we can. It might be too late for me to patch this out. I'm not sure. Where are we? We're right there. Let's let it continue to hear. I shouldn't have much in the pictures folder. Oh, I've got a really big file here it's going to have fun with. Especially the base 64 is going to be really slow. Oop, so slow that it's going to kill my debugger. Okay, it generated the new file. It is interesting to watch this in real time. There we go. All right, come back to me. There we go. Goodness. All right. Let's kind of figure out something on the fly here. Let's see if we can edit this out a little. Edit IL instructions. I'm not super well versed in IL. My apologies. I probably should have. Oh, that's interesting. Okay, so it actually has one of the encryptions is only okay. Oh, it only hits the personal folder if it ran into an exception of nothing running. Okay, that's rather silly. So it should be almost done then. Just has to encrypt my music, right? It did my pictures, did my music. Oh, yep, okay. All right, here we go. So we have some German here. I do not speak or read German at all. From what I understand, the extension means autumn or something. So, okay, so it did finish encrypting. Took forever on big files because it's reading the entire file into one byte array, which is very, very inefficient, especially if you're doing base 64 on it then. Now, the other fun part is, if we take a look, we saw that there's a decrypt function here. So like I said, I could literally just rip this and throw it into my own decryptor. I made mine a little more efficient though. Whoops. Old version uses Control R. We see the decrypt function is used by a button click. Okay. Now, it also looks like it only decrypts the folder that the executable is running from, the startup path. We see button one click. I only see one button to decrypt. I probably should have said a breakpoint. It might have already worked. So here's the funny part. It does decrypt on its own if you leave it running. Just move all your files to the folder that it was running from. And it's gonna bug out. Alright, okay, we did break. Alright, what are we decrypting here? Get past the getter. And go back to our locals. Alright, and we'll see also it encrypts multiple times. Because, especially since I ran from the desktop, it encrypted, remember, the first thing it encrypted was the path that it was run from. So it encrypted my desktop because I'm on the desktop. Then it went back and explicitly encrypted the desktop. So we'll see all these files have .erps. All right. Let's let it do its thing. So it's going to at least strip back. Oh, no, it does continue. Okay, so it did, it decrypted these files. Now, some of these might be okay since .py files are, you know, they're ASCII characters just by what they are. So we probably got this file back okay. Ooh, is it like really tanking here? And nope. Okay, so I bet what they did, I'm learning some new things as I'm looking at this. So did they like strip? Yeah, they didn't realize that it's encrypted twice. So they do a global replace of the extension instead of just stripping off the extension. So this file is actually encrypted twice, and they oh, they're gonna get on me here. They only decrypted it once. So we have to do the rest of the job and decrypt it again. Base 64. Decrypt. All right, this looks more like our actual file. So let's save over and reload. And yay, there's actually, that's what this file is Hasherzade's file to PNG. We'll see there's some garbage bytes here though, because those are like end of file delimiters or something. Not sure. Anything that was not like in the English alphabet basically gets lost, or the Latin alphabet technically. So that was gone. My poor crypto tester, which I'm not sure. Oh, I must have. Okay, it wasn't able to delete it, but it was able to encrypt it anyway. Okay. If we take a look at that in Notepad++, it's probably still got the base 64, right? I should have loaded it in the hex editor first. As you can see, this thing is very, very buggy. Come on. Okay, so anyway, the point is, it destroys a lot of files. Now, like I said, some files might be somewhat recoverable with a little TLC, basically, but kind of a damper when, you know, the victim gets encrypted by ransomware, and then even the criminals can't recover some of their files, which is sad, kind of ridiculous. But as we see, there's a lot of goofy bugs with this ransomware, so that's why I figured it'd be worthy of a video. I may still release a decryptor, just in case some victims did get hit by it several years ago. I believe I can't quite remember the name of the company right now, but they did release a kind of a quick little blog with some of the points that I went over. They didn't go into the bugs, but they just showed the general logic of the encryption. But they didn't release a decryptor or anything. I have seen to my website, ID Ransomware, some submissions. Actually, one was pretty recently, which is what kind of went on my radar, and kind of remembered about this ransomware. So I might release a decryptor anyway. I might have to finagle, try to fix some files if I can, depending on some formats, like maybe JPEGs. I might be able to recover some of it, but at least you can recover some files. Better than nothing. So anyway, that's been a nice little quick analysis of specifically looking at bugs at ransomware. If you have any questions or anything, feel free to drop them in the comments. Otherwise, I will see you next time.